Welcome back. From this video, I present to you memory management, especially how to allot the free available memories for new coming process. That is formal noun. We know the free available is it's called as holes, and so that from this short video, I present to you memory management, allotting this others. The number of algorithms we have, the number of algorithms in an operating system that is used in alternatively to allot the free available memories for any planning process. So that let's see those algorithms. There are 5 in a number according to the reference we are using. There are 5 in number. One of this is first fit algorithm, that is based on the available free space. This algorithm scans along the list of segments until it finds a hole that is big enough to the new process which is requesting to get a memory space. What the main concept in this algorithm is, searching is start from the start of the memory index, means from the start of the end of searches or accesses or to find the matching size for the new requested process. That matching size might be equal or more than the requested, but it cannot be less than. So from the searching from the start, it can find the first enough size, then it assigns this free space to the process. That means what I mean here is not mean to that the largest or the wider or the comparing all, but simply start scanning or searching from the start and finds a hole that fits, that may be equal to the requesting process, or it can maybe larger than, or it can be largest in the available space also, but finds whatever in the first search, in the first chance, that allots or gives this hole to the given process. Then the process uses the equivalent matching size and the remaining size to be reserved as free space to that is first algorithm works. The other is next bit. That is the same to the first bit, the same to the first bit. The only difference is the last search or the last search finds some hole that is matched for the requested algorithm or the requested process, and then this allot or this allot that hole to the given process. Then next time the searching starts from that point towards, not from the start. The only difference is this one from the first bit. The search starts from the previously where it left, or here it keeps track of where it is whenever they find a suitable hole for the last process. That is the difference, unless it works the same way. Searches for the big enough hole for the newcomer process, that's allowed that space means maybe larger than the requested process size. Then matching size given to that process and the remaining cut out that reserved for next time to be pre-resource to used with other processes. The second algorithm is the best fit. That's different from the previous two, that means from the first as well as from the next fit. The difference is that this just searches the entire list from the beginning to the end. Now the difference in this algorithm is searches the entire algorithm, the entire list, not algorithm, the entire list. That means there are memory blocks from start to end, maybe 1 billion entry, maybe 1 million entry, what the number of we don't know about, but assuming that there is number of entries or number of blocks that used to this process that is free, they are available linked list as recorded as a list form, and so that this algorithm searches the entire list from the beginning to end, takes the smallest hole that is adequate. That means exact match may be there by fit to the requested process. If this is there, it assign or allot that hole to the requesting process, unless it searches for the nearest enough hole that not be less than to the requested process. Enough. If no better, you can use any one, but it tries to find the most exact match for the this new request. So that is what that reserves larger area for other larger processes. That's maybe sound a good chance, but the assign process is maybe slow, but the usage is conservative, conserving, or means in wise usage of memory space as a request. That is, and the other next algorithm is the worst fit. The worst fit. Also, working strategy is similar to best fit, means as searching is to find the largest among the available holes. That means the searching is from the beginning to the end. That's same to the best fit. In the best fit, to find the exact match or smaller hole to that request. In case of worst fit, to find the largest hole among the available, so that that big enough to be useful will be allotted to the requesting process, and other mining part from that hole left to the reserve for next other user. That means splitting a hole to allot to requesting process, and their mining to be saved for next users, for next requests. So that this is different. That finds the largest among the hole. That's always take the largest available hole, so that the new hole will be big enough to be useful. The simulation has shown that worst fit is not a very good idea because it's a slow one, because searching is from the beginning to the end. The other is the breaking or splitting the largest hole, my extravagant, means the wastage of the holes may be that big. In case of west bit, that big to be reserved for other larger requests may be there. That's if it we use in this way, that's wasting. But the worst algorithm do not work in this strategy. So best bit taking us among these three is good side as. The other last algorithm is a quick fit. Quick fit, which maintains separateness from some of the more common size requested. So that is source and sorting model, so that find the size is very fast because it's already sorted. It's already sorted availability from the minimum to the larger, so that simply find in which index this process can be placed according to the size it is requesting. So that quick bit different from the other because of it has other separate lists. Other separate lists that request that manage the available holes based on the common request from the previous size. So that there are sort free available memories and list form, and so that easily find the index to be placed, the income request to be placed in which indexes, so that this quick fit taking us very fast to allocate. It's very fast to allocate. The difference from best fit is the working strategy is the same, because it's also searches for the allocate hole for the given process. But in case of best fit, it's simply searching, but in the quick fit is know where is that hole is, so that from comparing to the best fit, quick fit is very fast allocating. Okay, let's take one example to more clarify this concepts. As soon as we have this memory and type of form I use here to clearly indicate. Assume that this is the memory block. That's P indicates the process, H indicates hole, and beneath or the lar to the given H or P is the size available or size in use, which is current process or available to the hole. As soon as the polling is memory status, that is some part in use with the processor and other part is pre-available, means let 5 p which is process this 5 unit of memory block using is also philosophy to other process using 7 blocks. This other process using 9 blocks. This other block using 3 blocks. This other 6 blocks, and this other. So those was somewhat watery blue, which is in use. The sky blue, I can say sky blue, yes, which is in use currently within a process. And what you see here, somewhat the pink color is free space, or it's called hole. So the size is indicated here as you see here. So again, assumes that new process with size 7 arrive to the system that requesting memory, and if any one of the algorithm is in working, which means there might be best speed, there might be first speed, there might be next speed, there might be anyone, assume anyone is working there, to allot for this process we having 7 block need, or requesting 7 block free, 7 free block need, and any one of algorithm is working there to allot a pre-available location for this process. The whole to be allotted is then if the working algorithm is first fit, the allotted hole is H2 or hole 2. Hole 1 cannot fit because the request is 7. Yes, the request is 7 as is mentioned. To allot the 7, the 6 is less than 7. In searching, start from this index in case of first fit, searching, and then finding here H2 10. Yes, 10 is enough for 7 because extra also there, but 6 cannot be because it is less than 7. So that firstly find the hole that is big enough. So in case of first fit, it allots hole 2 to the this process because it's larger enough hole to this process, so that 7 among the 10 blocks of free available hole, 7 is given to that process, and 3 be left there as taken as free available for next usage, so that 7 in use and 3 available hole to be there in case of what? First fit algorithm. If the working algorithm is next fit, the searching in case of next fit is the same to the first fit. Also, it allots this hole 2, and searching itself from hole 3. Now hole 3 is in next time, since this 10 is more than 7, so that other hole 3 will be created here for next usage. That means 7 is given for now requested process, and 3 will be left here, so that searching start from that hole for next time in case of next fit. So that the only difference is searching starts as soon as that is consumed totally, so the search is started next fit from this toward that one, but in case of first fit, searching again starts from this toward. Thus there are one advantages and disadvantages. If the working algorithm is best fit, the allotted hole is for the process which is requesting 7 size of 7. The working algorithm, if the working algorithm is best fit, this algorithm searches from the beginning to end of the available holes, and then finds the advocates hole for the newcomer process, and the newcomer is 7 size, 6 is not fit, 10 is more larger, 8 somewhat equivalent, not equivalent, somewhat best to assign other than 10. 12 is very large, so the best fit, if it's not equal to the requested process, sorry, this best fit allots for the newcomer hole 3, and so that 7 is used in that process, and 1 block is remained there to be a free available memory. So it's nearest to the requested, also not equal fit. Even it's not equal, but is assigned, and there will be one remaining block to be free out of the usage of the requested or if the requesting algorithm or the working algorithm currently is worst fit for this process, means this process means process requesting 7 pre-available location with size 7. So if the working algorithm is worst fit, it allows whole 4. Why this is? Since searching from the beginning to end and find the largest enough hole, that is strategy of worst fit, so that the largest enough amount this is tail. Because of first fit, find searches from the beginning to find the enough hole. If 12 is there, first bit allot 12 to the process, because firstly find the large size that is enough to the new requester process. But in case of this case, it searches all holes. But in case of first bit, it stop here until got the enough size for the newcomer. It stop there. But the worst bit no stop somewhere. It search for all entire available holes in there, then select the largest hole, then allots the amount required to the process and minus the remaining tiny holes to be reserved for next usage as free space, so that the tail or H4 or hole 4 is allotted for the newcomer process, and so that 7 is used with that process and 5 remains as free resource or free memory, since it's the largest in the available holes because of course selecting H4. And the last one, which is quick fit, allots H3 for source record of available free holes. It is faster than best fit. The best fit also allows H3. This H3 is by searching entirely available holes, but in quick fit this H3 is directly find from index where this is located. This where is located, so that easily allotted. So from this example, I hope you will get the create idea or the clear idea to create your mind how the algorithms allot free available holes for a new coming camera process. If you have any doubt to the clear idea, you can ask using a comment link and video link inside the link. Bye for now. I'll be back with other tutorial next. Bye.